Hello everyone, today we're gonna do an agent-based portrait in Grasshopper. We're gonna use Culebra, the plugin for agent-based stuff, and image sampler. And we're gonna do that using a portrait of Jacoba Mulder. So she was an architect and urban planner in Amsterdam, and we, Robot Lab, are moving there soon to the building, named after her. So alright, and what we will achieve in the end of the tutorial is this kind of agent-based system that is using some flocking, some processing that we put there, right, based on image sampler. And I invite you to explore, but first I'd say let's start the tutorial. So let's start by creating a new file, and the Rhino should be in millimeters. And first we're gonna put the size of the portrait. You can just put pixels and check it. Check just the image settings. So because I know mine, I'm gonna put it, and if you work with the same one, it's obvious. If with the same portrait, it's obviously same number. So okay, something is wrong. Okay, and pretty much I need to first construct a grid that I will later use for image sampler. So, and we'll do that without the grid component because it's a bit heavy. We'll do that through series. And maybe let's reduce though the number of these guys. I do that through expression. It's actually really important to know maybe that if you want your script to run faster, use less division and more multiplication, such as what I just put, 0.1. Okay, same will do here, so I just copy and okay, maybe actually we need a bit more. Let me calculate. We divide it by 4, how much it will be. Of course you don't have to do this in advance if you want to try something else right after, but it's good to calculate in advance, otherwise you might end up with the resolution will be too high or too low. You can change that later, but since we already do something that I already done before, we're just gonna go through by okay. So now it's too little. If I use 25, okay, this looks much better. Okay, let's use this thing. It's just a little bit more resolution, just doesn't feel right. Okay, so we will construct the point. And we'll use these guys as X and these guys as Y, and you see something doesn't add up because we need to make this, we need to graft it. In this case, well, I hope you know something about data structure. Otherwise, yeah, otherwise it's difficult to actually work in Grasshopper. All right, so this part we constructed a grid. Actually, it's a good habit to name the blocks after you finish them, because at some point it starts difficult to navigate, and yeah, you might want to help yourself in this way. So okay, we need the bounding box of this union box. Yeah, flatten. We take those points. So flat box, that's what we need. Let's also flatten 3 here and use surface closest point. Okay. All right. Reparameterize because yeah. So it's like it makes it from 0 to 1. And here we're gonna put actually our image sampler. Okay, so file path. This guy, well, this woman, what I mean, the portrait. And we're gonna use only like blacks and whites, let's say. So, and it's actually, it works better with this component, color brightness. So I press OK. Okay. Okay, he doesn't have. So, and why we are doing it in this way? Because it just works much better rather than just putting the points. Okay. So we actually here got like the parameters that got reparameterized. What we got is that like each point and the intensity, right, from 0 to 1, from white to black. So it is relatively simple. Okay. We may also create a container for bounding box. Bounding box for the future. Okay, and group it as image sampler. All right. Okay, so now what we want to do is that we want to create a gate of what is interesting for us and what is not. Or, I mean, interesting, I mean, like my design decisions in this tutorial, but you could have other design decisions, right? Essentially, I just want to separate like more black and more white, more like shadows, let's say, and more light in this case. So to do that, we go through the component larger than. You can also do it through the expression, but I think it's easier this way, especially if you are not, if you didn't spend a lot of time with Grasshopper. So let's say it will be 1045. This number also can be changed, right? So okay, and I'm gonna dispatch based on this. We're gonna dispatch our points, and the pattern, we'll use this one. So in here we have, yeah, pretty much bright colors and dark colors. Okay, let's check. Ctrl A, preview off. Okay. Well, I mean, if you change this parameter, you can also have a bit different stuff. But I advise you to do it after tutorial. First follow it and then play and change and so on and so on. Okay, fine. So, and I also need the intensity value, or like yeah, the darkness or lightness value, let's say. And I'll use remap because I want them in a bit different way. So for how remap works is that it remaps a certain value that will give, right, that comes from image sampler. You use source domain, which is the domain from image sampler, and the target domain can be whatever you want. And I want, for example, my domain to invert it first, the intensity, and I want it to lower a little bit for now. So to do that, we take the parameters and yeah, we flatten them. We get the domain. We get the value from here, and we need to construct domain, right? Which is, in my case, it's 0.6 to 0. So it's kind of inverting it because it takes 0, I don't know, well, you see it's long number, 0, 1, 9, blah, blah, blah. And it makes this one, this, because it's domain start, yeah? So, and it's kind of inverting it. Okay. We connect it, so you see our target domain and our source domain. Alright, and we have our map. We also always check the data structure and if everything is flattened, if the number is the same of the components. It's like the main things you need to always kind of check before you connect nodes, because if it's a mistake, the files can crash, which is not such a big deal, but still it's better to avoid it. Okay, we use the same dispatch pattern because we need these intensities with these points, right? So these are the points and we need the intensities of each. So let's name them so we don't forget. Bright intensity param and dark intensity param. Okay, so this actually I'm gonna put I'm gonna group things that you can change easily, but I mean, to be honest, you can change a lot of stuff. It's just things that really will really change the design solution, right? Gate for black, white. Okay, let's group it. Division. Black, white. Okay. What did I do? Align? No. Alright. So. Okay. And then one of my design decisions was also I want like an area where I kind of frame what's important and what's not, because, well, yeah, I want a frame that pretty much frames the face, frames. To do that, you can, yeah, I mean, we're just gonna draw, and of course this can be changed later. It has a grid snap. Alright, so it's just like free form kind of thing. not gonna close it because we can close it in Grasshopper, and we will be always sure that it's always closed. So we take the curve, set one curve, right? When we clicked on that one. So now you see it's referenced, right? Referenced. Okay, and we can actually hide it for now. So then we close curve. Yeah, I mean, just in this case, we're always sure that it's closed one. So I think that's why I do it this way. And then let's name it curve that frames the face. Okay. Hidden. Okay. And now what we essentially need to do is that we need to check if the points are inside of the curve, and if yes, then we like separate what is inside of the face and what is outside. Okay, to do that we'll use the point and curve component, and yeah, pretty much it's relatively straightforward. You have the point, you have the curve, yeah, and you have the relationship, which is 0 outside, 1 coincident, and second inside. And we'll use shift pattern to kind of separate these values, these points. And we take the list, we take the pattern, yes. And what we're gonna do is that we pretty much 0 and 1 will be around. We will use clean tree because shift pattern also create nulls, and it's good sometimes for keeping data structure, but for us it doesn't matter right now. So, and then this one is yeah, this one is inside. In bright points. Okay, just name it face and a round face, and I want to cluster it, so you can just easily copy, and then you can learn how to do this as well. Okay. Actually gonna just do like this. Control Shift to take it out. Yeah. So, and then we're gonna cluster this guy. Yeah, that's fine. Cluster. Dramatically reducing the space. Alright. So, and now we can name them bright points, round face, and bright points face. Alright. Well, we do the same, right? I say right a lot. Yeah, actually, let's go back and let's copy these. To go inside the cluster, it's double click, by the way. Maybe I didn't say it very clearly. Let's put also parameters as well, because we anyway gonna use one pattern, so, and cluster input. Okay, we will put it later, right? That's why it's yellow or orange. And we will name them vals, which means values, right? Not points. Face vals. And we need also cluster output, of course, because we need to take this out. Okay, that looks fine to me. Yeah. Okay. So we take the parameters here, and yeah, and then just instead we put in the second one dark colors and dark parameters. Okay, and we will rename also this dark points, dark vals. Okay. Fine. I think we're good. Maybe what we can do is that we of course group this as face around face. I don't know. We don't have a better option, but I think it's kind of clear. And this one we can group in the same way as we did others, with the I use some kind of like bluish color, so that means that you can, if you change it, it changes a lot the design solution, right, or the outcome of the system that we are building. Okay, so next step. Yeah, next step is pretty much I just would like to reduce just want to reduce some of these ones because I feel like they are less important around face values. So for that I'm not gonna do anything very special. I'm just gonna use random reduce, right? But you can you know, like, be creative about it and do something else. So for that I'm gonna reduce till something, so that's why I'm gonna use the list length. And here I want to specify how many points I want. So random reduce. And yeah, pretty much let's just take the list, the reduction, right? How many items to remove. So you see we end up with 90 and 989, same as we specified here. And you can put the seed just to change if you don't like something. It's kind of easy and fast way to achieve a lot of options with very little, you know, efforts. So yeah, kind of lazy way to do these things. Okay, and we do the same here with values. Maybe. Okay, you know what? You already learned how to do the cluster, so we're just gonna do it in this way. Okay. So this is the reduced list, right, and the intensity. What I'm gonna do though, I'm maybe gonna add a little bit. Yeah. Okay. Okay, and let's also use similar approach to the dark values, but maybe just even easier, because I think the logic is clear what I'm kind of doing here. Yeah, and same goes to the values. Okay, so what I do usually is that I always kind of keep these parts after each operation. It just makes things less messy. And when you start to work with bigger files, you kind of feel the difference. So this one we will connect with this one we connect with that one. You can also, if you really dislike spaghettis, and yeah, you can do this, just hide them, can be a good idea, but at least just I think at least you can just connect the values. Yeah. Okay, we'll group this as reducing points, and yeah, let's just kind of visualize for ourselves here before we go to actually to Culebra and try to do some agent-based crazy stuff. Well, not crazy, but different, I would say. Okay, we will visualize it just with circles, but of course you can use something else. That's always welcomed. Yeah, we use plane, we use radius, radius from around face values. Yeah, and same pretty much face ones. Okay, Control A, preview off. What's wrong with my mouse today? Yeah, so we kind of have this. And you can actually maybe reduce values or increase it. For example, yeah, let's increase it. We can put x, right? Multiply by 5. Yeah, and just to have like nice image for ourselves, we put custom priv, and two of them with two different swatches. Swatch, and yeah, well, I'll put maybe like pinkish kind of color, and same here, maybe a bit different, maybe lighter, can be, yeah, I mean maybe not, well, anyway. Please feel free to do something else with that. Okay, I mean this is kind of preview for us, so do not overthink it either, and we do the same as dark ones. Right, point value. That's kind of funny. Can use something. I mean, yeah, you can make these smaller, but it really doesn't matter for now. No, it was not the right one. Okay. Yeah, something like that. Okay. Cute. All right, I'm just gonna group this as preview. Yeah. So what we did here is that we obtained the points, we obtained the intensities, we divided them according to different design decisions. So let's continue. Okay. One second. Okay, anyway. Let's go next. We'll create the agents that will initiate the points. So yeah, a little bit of I promise it's just a little bit before we actually go to Culebra. Well, I mean, if you enjoy this, then it's fine. But okay, I think what interests me the most, but maybe you have like different point of view, right? That's why we created all of this, and I showed you how to do other stuff. Is dark points phase, because I kind of want agents to create, yeah, like kind of shadow that moves maybe somewhere. So I take dark points phase from here, right? I copy, hide it in order not to create maybe too long kind of canvas. So I obtain okay, let's say we have the bounding box. And union box. And what we're gonna do is we're gonna calculate how far the points are from the center. And according to that, we will have like our values for yeah, like we'll have more points in the middle and like less points outside. So because in the end of the day, like the face is more important for me, right? And maybe for you, you decide otherwise, right? Okay, so but we're gonna do that by obtaining the area centroid. That's what interests us, and we will calculate the distance between points. So this one goes here, the centroid goes here, so it calculates the distance between each point, right, and the central one. And we will use it as a parameter to sort them. So we have keys, distances, and values points. So yeah, and I maybe want to change it, or like concentrate here, as I said, right, and less there. So I'm gonna do that through graph. I'll show you how. We have our list here, and we will create a range with the length. Only put expression x minus 1, because that's how like list length calculates, and Grasshopper starts from 0, so that's why. Construct domain. Maybe I shouldn't do this so late. Okay, let's say from 0 to 2. I mean, so we have the range from 0 to 2, and we'll put it in Grasshopper, and I'm gonna use just Bezier curve. So what I want is something like this. And actually I want also to do from 0 to 2 because I put it here. So yeah, something like this would work, I think. And I want to create them make them integers because I'm gonna use it as a mask to divide to divide the values. We use shift pattern again because it's the theme of this tutorial. And then what? Okay, so this is the most important part. Well, maybe like this. I don't know. It's hard to decide. Well, decide by yourself, I would say. Kind of want. Okay, you know what? Let's just try like this. Okay, so that means these points, we take them all, and others we reduce. Maybe that's a lot. Maybe that's fine. Okay. Others we just merge and we clean 3. Yeah, remove nulls. Cool. And our favorite random reduce. We'll do the same thing as we did before, list length. Sometimes if you use something a lot, just create user node or like user box where you just use some clusters, right? Same as we did the previous one, but it kind of helps if you always use similar methods, which is you also kind of end up doing that in a way. Or there are like basic blocks that are applicable in many cases. So okay, I think it's fine. Let's merge it. Well, I think it's gonna work. Let's in case let's flatten it. Just name them init points because we're gonna kind of initiate our agents in those points. Okay. Alright, and now let's finally go to Culebra. And let's find it first. Okay, cool. So pretty much we need to spawn agents, right? We need to do some settings like in the beginning, And then there are different behaviors. We, for example, gonna use flocking in this tutorial and multi-pass tracking, but there are a lot of cool ones. Actually, this one is 3D, so if you want to build a portrait in 3D, feel free to explore. Also, yeah, the Culebra, they have pretty nice example files, so there you can learn a lot. We also gonna use attraction force. You can also use repulsion. Bundling is a bit different, but also could be tried. Why not? Yeah, and the difference here is that we're gonna use just a normal engine, but then zombie engine means it just kind of calculates and you don't see the simulation happening. I would recommend it to use only when you already build the system and you don't want to make any changes there. So and maybe you want to use it with evolutionary algorithms and things like that. All right, there is also a lot of cool stuff, but we just kind of gonna try to keep it more or less simple. Fine, let's bring init points here. Gonna connect and hide the display, and we need the point spawn from here. Yeah, and the bounding box is so the bounding box is the one here. Yeah. Okay. We just connect it and this, and it becomes black when it's fine. So that's a good sign. Okay. So we just need init settings, which is here, and spawn setting. Well, in case, let's flatten them just to be sure, because yeah, well, in this case it's fine, but sometimes it can go wrong a little bit. Then we need the dimension. 5.0 2D and boundary bounds 0. Doesn't work. I mean, I know why, because it needs integers. Okay. You can also use panel, maybe it's a bit less frustrating for the, because you anyway probably not gonna change this a lot. Well, maybe you will, but still. Okay. That is fine. And then we need to initialize move settings. This is like initial kind of stuff and more general things. So I want the first move they do kind of be up, sort of thing. So, but it's gonna have a lot of also other forces, so it doesn't necessarily mean that it's gonna go there, but it will kind of try in the very start. Okay, that's fine. Just unit vector, and we will change it through the amplitude. In this way we can, yeah, if you put, you can maybe use some other vectors, it's just kind of easier a little bit if you want to change things later. Okay, so we just connect it to our initial vector that also has speed as a value, and gonna put some stuff. So these kind of things, honestly, it's like, be very careful when changing them. Change one parameter and then see how it affects it. Do not change everything and then see how nothing works, you know, kind of do changes and see the simulation, because this is agent based, which means it's all about local rule sets, and one small things can kind of lead to a bigger change in global behavior, right? So you might want to be a little bit careful about it. So okay, let's bring our engine, although we didn't put anything yet. And I think we need timer also. How it was it trigger? Was it time? I think it's timer, okay. Okay, you know what? I'm just gonna copy this from one of the files. One of the files you can download with the plugin Culebra. The whole setup, because anyway you're probably gonna do that with this. Yeah, it's timer. Okay, anyway, when you download the plugin you will have the examples, and you can just kind of get the whole block with the whole thing. So you can also actually check these kind of small parameters, because it's helpful if you decide to do something dramatically different. Okay, now what we need to put is our behaviors. We do that through, because they have several, we will need a controller. Where is it? All right, we'll have 3. So okay, let's build our first behavior, which will be attraction. Yeah, like attractors force-wise. So we will use the dark point face from here and a round face. And actually we can just copy everything, because we also need values. So you can do it this way. Okay. All right. Yeah. Okay. I did everything. Okay, we'll bring it here, and we will create attractor points. We merge it. With face first and around later. We'll also merge it, but first we maybe make this smaller. I know I told not to use division, but I anyway have a very simple setup here, so there is no point to overthink it. Around face. Okay. Okay, fine. Yeah. And we will bring attract behavior, which is forces actually. So these points will be our attractors. Yeah. All of these. Can do something else, but you'll see that actually because we initiate them and tell them to go up, these points are kind of useless, but still. It doesn't matter right now. Okay, and let's remap our numbers, I would say, just to make them bigger. Bounce, we check the current domain. Yeah, definitely I want to make them bigger. I mean, I can also multiply them, but I think in this case we can easier change the values we want, and like it's more controllable somehow. Not somehow, it is more controllable. Okay, fine. So we just put the maps to thresholds. You see how big it is? Anyway, and attraction values, I would recommend, yeah, also to just put the same ones and later on kind of carefully change it and try others and so on and so on. Yeah, well, pretty much straightforward. It's the magnitude, yeah, and the maximum attraction value. Okay, so we have our first behavior here. Then we'll name it attractors. Then our second behavior will be path tracking. For that we actually gonna create something. Let's put the simulation here, and we're gonna do very quickly. This is kind of ugly, but I turn this off. We're gonna just take again dark points face, and we're gonna create kind of a track. We will group them through point groups. If it's a large one, there is a nice also component with machine learning in Lunchbox plugin, but I think we don't have enough. Yeah, it's too small. So anyway, but we group here like based on the distance. Okay, we have certain ones. Then we deconstruct points. We sort based on the values, and we create polylines. So okay, that's not what I wanted. I know why. I think if it's 3, Preview everything off. Okay, this looks like what's closer to what I thought. It's kind of like agents will kind of try to follow this, but honestly, yeah, it's just for you to know that this is a possibility. Okay, we created a lot of nulls, so we will clean the tree. Okay. All right. So this will be our lines to follow. We do similar stuff by copying and bringing it close to where we're gonna initiate the behavior. The behavior is this one, and we just kind of feed the, yeah, like the polylines. Okay, I'm just gonna put some random numbers. Okay. Tracking. We feed them to our behavior controller, and now we create flocking, which is like similar idea, right? That birds do that, so you have like local rule set, which is kind of align, separation, cohesion. If you don't know like this concept, you can Google, the internet is full of this stuff. Okay, so connect false, view angle. So these kind of parameters you can change, and you will see the changes also in the system. Search radius is like, yeah, the radius when they recognize another agent. Align, yeah, well, the diagram would help, but as I said, it's full of this stuff. So if you just type maybe like flocking rule sets, you will definitely get it. Okay, flocking behavior, we connect it to controller, and I'm gonna just bring visual settings from also the example files, because it's simpler and faster. It's the last component, by the way, that we need. It's we kind of say if we need the trail and what's the size, and geometry is the trail, graphic is not. Okay, you'll see. We put the behavior data object, we feed it to our simulation, and as you see, the last part is visual settings. For us, it doesn't really matter a lot. Okay, let's see. Okay, I think we need to also bring, yeah, the preview settings. Okay, so we are very close, but let's just kind of preview it in a nicer way. Okay. And let's say points, we can have cloud display. We have points where they are, right? Swatch can be kind of pinkish. and size. Okay, 1 is fine. All right, I preview everything off through Control A here, Control A. Okay, fine. You can later on also take this curve and use components such as reduce polyline. Then you can use smooth polyline if you want different, you know, filling or maybe less points and so on. Rebuild curve, you can use them all together, you can use them separately. So, you know, feel free to also explore how to post-process the result of the simulation. But for now, yeah, you can see that we have mesh. Yeah. Anyway. All right. So I hope everything is okay. You liked it, everything is clear, everything is successful, and so on and so on. Right? This one is kind of funny actually. If you change different parameters, you end up having very different results. I don't know, such as this. But when you change something, you need to reconstruct the simulation, right? So, yeah, like you can do a lot of changes and like really explore it and so on and so on, right? And if you want to 3D print it or mill it later or just draw with a robot, you can take the trails, yeah, or you can use a multi-material process or so on. So yeah, it's very different how you approach it, but I think this kind of framework is interesting because it combines a lot of just standard processing, right, through dispatching and more kind of agent-based, more, yeah, like generative part. So it's like really in between, you know, like top-down and bottom-up sort of control of the thing. Actually, maybe if I change how we started this, I mean, the idea is that you change things, you have very different results, but you can, and you should, I think, also try different behaviors and try different modes. It's all very interesting to explore. So, like, yeah, it's, you know, it's a kind of playground and we see what emerges, right? Like the recipe is just to be curious curious and explore. Okay, all right, yeah, thanks, and hope everything was clear.